So, welcome to another lecture by yours truly, Professor Francis Fiske, on C# loops. Today, we're going to talk about the vaunted while loop. Let's get started. So, what is a while loop? What is a while statement? Well, a while statement is an iterative statement, just like other loops are, for each, and whatnot. And what while statements or while loops allow us to do is to loop through a specific block of code based upon the assumption that a Boolean expression evaluates to true. So normally when we do while loops, we want to do a while loop in a way that allows us to continue to iterate over the blocks of code that we have to ensure that the end user reached the end result that we desired. We call this an exit condition. So the end user reached an exit condition within our while loop. And so what the loop does after that is it then decides for itself, okay, I'm finished. I don't need to do anything else. And what happens is, from a code stack or a stack trace perspective, is that when the while loop runs, the code really just sits at that stack, that part of the stack. And when the loop finally realizes that the Boolean expression is no longer true, then it stops. We call that a sentinel value. It stops the loop. It doesn't iterate again. It goes to the bottom of the loop, right, where the last curly brace is for the while, and it starts to evaluate programmatic statements and expressions and whatnot afterwards. So let's restate the obvious, which is a while loop is a loop that iterates until we reach a sentinel value via our Boolean expression that evaluates to false. So as long as this is true, or while this is true, do something. Okay, great. So that's really the nuts and bolts of a while loop. Let's go ahead and pop over to the code and let's see how to develop this. I was hoping to use Visual Studio on my PC. My PC is chugging right now, and Visual Studio, oh, there it is. It finally realized I was going to go to REPL, so it opened up. So what I'm doing right now is I'm going to use Visual Studio Code from now, or Visual Studio, I apologize, from now on, because I actually think it makes sense to show you how these things are working in the IDE. And what's nice about that is Visual Studio allows me to debug, which is something that I want to do in our course material. But we're going to do a console app, nothing fancy. If you want to write a web app or a server app, that's Blazor. Blazor's a nice way of trying to do a spa or something like that, or even a class library, you can. But in this class, we just want to use the console. We're just going to do a console application. So I'm going to go ahead and click next. And from now on, this is probably the app that I'm going to use the most for our teaching sessions, our lectures. So I'm going to name this one, programming in, I'm going to say .NET, so I don't have to use, or programming in, I would say .NET, but programming in .NET is the framework that we use when we're developing in C#. When you're developing in Java, we call it the Java development kit. In C#, we call it the SDK, or we call it the .NET framework, .NET Core. And then what I'm going to do is, instead of installing it here, what I'm going to do is I'm going to install it on my C drive. It's very important that when you first power up Visual Studio and you start trying to, if you don't have a repository in GitHub or something along those lines, that you create a folder in your C and or data drive and you save your files there. Because if you save your files where you see right here is trying to save it to my profile, if I try to save the files to my profile, what actually is going to happen is I'm not going to be able to run this in administrator mode. Now you might be saying, well, why not? Well, you won't be able to run it in administrator mode because Microsoft implements least privilege. It's a paradigm that is implemented across all Microsoft products, which means this: if you have a privilege, if you have multiple privileges or layered privileges on a specific object in Windows, whether it's the operating system, an application, whatever your lowest privilege is the privilege that you will be assigned. So on your PC, if you have a Windows machine, you are the administrator. That is true. But in your profile, you have a separate set of permissions. Your permissions in your profile state that you are a contributor /owner. That's not the same thing as being an administrator. An administrator means you're allowed to mess with the operating system binaries. You can install applications, you can develop things, whatever. But when you're just an owner, that's not the same thing, right? You're not an administrator. You can't run things in administrator mode. Now, some will argue with me about this. Please do yourself a disservice and try to create your project in your profile. You will find that you cannot boot up that project in administrator mode. And if you want to debug, you have to in most situations. So instead of doing that, what I'm doing right now is on my D drive, which is the drive that I normally use for my, the things that I'm doing. I'm going to create a folder. I'm going to call this lectures, programming, something that will let me know what I'm doing. I'm going to select that folder. Now I'm selecting that folder because I have full rights over the D drive. The D drive, I have no layered rights there. So my rights, my privileges as a user of my computer for the D drive specifically is administrator. So I can actually do whatever I want in this place. Now, please understand, and I'm going to say place solution and project in the same directory. That's fine. Well, no, actually, we'll do it the other way around. Don't check that box. But if you don't have alternate drives, you're fine just going to your C drive, right-clicking the white space that you see, and then just creating a folder directly in your C drive. Don't do it in the Windows folder. Don't do it in any other folder. Just right-click like you saw me do there into your C drive. If you only have a C drive because you have a laptop or whatever, right-click, new folder, name it something that you're going to remember, repos. It's probably what I should have named this. And that's now what I am going to name it because I wasn't thinking. So I'm going to come back in here and I'm going to rename this to repos. I like that better. It's in the repos. I have my solution name programming in net. Project name and solution name are the same. That's good. We're going to click next. It's going to ask me what I want to use. I want to use the longest, the most recent. Because I'm developing on my own, I can use the most recent .NET framework. So that's what I want to do, .NET 7.0. And then create. And now it's going to create my console app. Now, when it creates the console app, as we've been developing in REPL, what you will see is that the console app will resemble what REPL displays to us as far as the main, the class name, the namespace, the imports, the usings, if you will, all of that. So I don't know how long this is going to take because my computer, you can't hear the fan, but it's really going at it. So if this takes a little longer than a few seconds, we're going to pivot right over to REPL. And in the next video, we'll use Visual Studio Code or Visual Studio instead. It looks like it's doing the things, but I'm going to be patient. Though I don't know how long I can be patient. But yeah, so either way, like I said, the one thing that is going to, and I want to go back and forth between, using Visual Studio Code. I'm sorry, using Visual Studio and using REPL because I think it makes a lot of sense to know how to do both. Let me go ahead and pull up, I think I'll just publish a REPL. I'll create a REPL right now. Let's do it in C#. We'll call this one lectures. And then we'll say create. While this is booting up, if this just so happens to finish by the time I am done with this video, we'll use it in the next video. All right, great. So while loops, right? Let's do something. So right now, let's go over a few things. We have our using right here. This is our library. We have our class. Our class is defined as name program. Notice we're using a specific casing strategy here where the first name is capital. Did it work? Oh, nice. It's up. This is weird. Where's the rest of the code? I guess this is the way it's supposed to look now. I've not used Visual Studio 2022 yet, but I feel like we're missing something. Just a hunch. Maybe it's .NET 7 I've not seen recently or yet. But I'm interested in seeing the rest of this. There's a new template. It's not showing what you saw in REPL. So I'm going to pause this. I'm not going to use Visual Studio until I've gone through all the nuances of it. So let's go back to REPL. And what we're going to do is we're going to implement a while loop. Okay. So I'm going to say while. And now what we can do is we can define what that while should look like. All right. So we're going to say, and we're going to do a quick while. So we're going to call it int counter equals 0. while counter is less than 5, I'm going to say hello world, and then we're going to increment counter by 1. So what's going to happen is this is going to iterate over counter as long as the value of counter is less than 5. Right now, counter will be assigned the value of 0. Therefore, counter is less than 5 in the first iteration. Now, I'm going to run this, and as you can surmise, what should happen is console.writeLine should print hello world 5 times. That's what should happen. And it should stop at the 5th time. Now, you might be asking, well, hold on. That says 5. Why would it stop at 5? Because in computer science, we always start counting at 0. So the first position or the first iteration is the 0th position. So the way this iteration would count is 0, 1, 2, 3, 4. Notice that's 5 iterations. And then it will stop when it realizes that counter is no longer less than 5. And this is how while loops work. It's time for a mind-blowing exercise here. This is not how I would recommend writing while loops. As a matter of fact, an industry standard is to never put a Boolean expression in your while loop. There are people out there that'll fight me on this, but it's the truth. What you actually do is completely counterintuitive. Instead of saying counter is less than 5 and waiting for the counter to reach 5, what you actually should do is you should say that this while loop is always true. That means that you don't have to worry about adding multiple expressions to this while loop that add dependencies, right? Let's say you had multiple things you wanted to check, and if one of those things was false or all of them was false, you want it to stop. Well, you would have to put it inside this area in the top here. And quite honestly, this could cause what we call a tertiary dependency. A tertiary dependency is a dependency you don't know you have. And those tertiary dependencies can cause what's called a race condition, which is a condition that happens or an exception that throws that doesn't throw all the time, but throws in certain situations that you are unaware of. Normally, if you have your grandmother or your mother as a QA, quality assurance, or QE, a quality engineer, to test your code, 9 times out of 10, they'll find the race condition because users know how to break your stuff, even though you developed it airtight the way you think it is. But in this case, we're not going to say counter is less than 5, right? We're not going to do this. And the reason why is because if I have multiple conditions, well, I don't want to overload that while with multiple conditions. What I actually want to do is I want to create what's called exit conditions in my code. How do I do that? Well, first of all, this while is always true. It will always be true, and I really don't want it to ever not be true. All right? The reason why is because when I come down in here, I can ask myself a series of questions. I can say, if counter is less than 5, stop looping. So what are we looking at right here? Well, we did, in a roundabout way in the last module, talk about jump statements. And jump statements are very nice because jump statements give you the ability to do certain things that you wouldn't necessarily be able to do otherwise, right? So what does this break really mean? Break is a reserved word. And what break means is that whatever you're doing right now on this looping, and normally is for loops, right? But whatever is happening at this moment in time, in this part of the call stack, in this part of the stack trace, I do not want you to continue any further down this stack trace. I want you to go back to wherever you were and continue whatever you were doing before this structure was ever encountered. So within the context of this while loop, and I'll put some spacing so it makes a little more sense. Within the context of this while loop, what we're essentially saying with this break, it's the same as what the while loop is doing when the sentinel is reached. So if I put the Boolean expression back here, right? This is our Boolean expression. It will define a sentinel value. The sentinel value that we are looking for is anything equal to or greater than 5. Once counter is equal to or greater than 5, stop counting. Don't go any further, right? That's what that is actually saying. But we set it in reverse because we want it to be true. As long as counter is less than 5, keep looping. When counter is equal to or greater than 5, stop looping altogether. Or if I use the jump statement correctly, break. Now, where is the break in the loop? Can you guys point, if I erased this if statement for a second, and I put it back the way it was, where is the break in the loop? Pause it here if you want to actually think about it for a second. And I'll give you some time to actually churn the data for a bit. All right, well, if you've restarted the video or the lecture, what you will find is the actual break for this loop is implied at line 11. Line 11 is where the break is. So when this guy is false, when it finally comes back false, because that's what you want. You don't want an infinite loop, right? This curly brace is where the break is implied. And then every line after that is going to run. It's just going to break. So instead of doing that, what we're going to do is we're going to explicitly call the break. Explicitly call the break. So what's implicitly calling the break? Implicitly calling the break means that the break is kind of encapsulated in the code. It's not readily visible, all right? But it's there. We just might not be able to see it straight away. Explicitly calling it means that you are absolutely 100% being open, honest, and transparent about what's happening there. When you write your jump statements, you are explicitly telling the code to do something, and it's evident to other developers who look at your code. Okay, without belaboring the topic, let's keep going. So industry standard is do not put a Boolean expression in your while, always do true. And then create break or create exit conditions to get out of the loop when you've reached a place that you're like, I'm cool. You can also use another exit condition when you don't want the loop to continue. Just go to the next iteration. So let's say if I said if counter equals 3, continue. Now I'm doing this for the sake of our lecture, because continue is one of those words that isn't used nearly as much as break or go to, for that matter. Go to is another jump statement that we use if we want to go to a specific line based on a specific, outcome, right? But we're only going to do break and continue for now. So break stops the loop in its tracks. When this happens, exit the loop, period. All right. So I'll put a little comment next to it. Exit loop, don't run anymore. Your continue doesn't necessarily do that. As a matter of fact, your continue statement will break the iteration. But if the loop can loop again, it will loop again. So what this does is stop this iteration of the loop, start new iteration. Now, to give you some more context, the word iteration means when it is looping. Every time it loops, we call that an iteration. Every time it loops, we call that an iteration. So when we are in an iteration of the loop, right? So let's say we're at the third iteration, because that is what we're tracking. If counter equals 3, or fourth iteration, my apologies. If we're at the fourth iteration of the loop, I don't want you to do anything else. I just want you to continue, which means don't run any of this stuff below 13. Don't run it. When you get to continue, don't run any of this stuff. Go back to the top, check to see if the sentinel is true, and then loop again. So let's see what happens. What do you think is going to happen? Pause the video, run this yourself. Find out what happens first. I'll wait. All right, well, if you've paused the video and you realize what the answer is, well, you will find that the answer is quite interesting. It will stop iterating when counter equals 5, but there's only going to be 4 hello worlds, because we told our while loop that when you hit the fourth iteration, which is 3, right? 0, 1, 2, 3. Once we hit 3, do not do anything else. I want you to go to the fourth or the fifth iteration, my apologies, when the counter is 4. And so it won't run the console.writeLine for the fourth iteration or when the counter is 3. I said run and it didn't do anything. Oh, I wrote this wrong. It'll never run because counter was less than 5 the whole time. My apologies. Counter was less than 5, it didn't run anything because it broke. So let's flip that, right? If counter is greater than 5, break. So now it should run the right way. And there you go. What's interesting is we only received 3 hello worlds. Now, I wonder why that is. Can anybody tell me why that is? I said we received 4, but we only received 3. Let's take this code and let's dump it into Visual Studio Code. And let's debug it. Oh, there it is. That's what I want. Sure. Auto-generated. So it looks like I have to build this whole thing by myself. That's interesting. All right, cool. Let's just take what's in Visual Studio Code and dump it into Visual Studio. That's interesting. Why did it do that? I don't know. All right, here we go. All right, so this code should run. But what I really want to do is using G. No, I don't do that. Don't save. I want to take that and do that. Perfect. Save. All right, so now we have our program written out the way we want it. We have our counter at 0, our while loop at true. Let's go ahead and debug this. I want to find out what's actually happening. So I'm going to go ahead and click. There we go. Go ahead and click the side there. I want to stop looping when we get to the, I want to break at, we're going to debug. So I want to break at the while. And then what I'm going to do is we're going to start debugging. I'm going to hit F5. What should happen is it will build, and then it will show me what's called my immediate watch. And it will show me the things that I want to see directly in the code as it's stepping through the code. There's 3 things you need to understand when debugging. The first thing is that when I click F5, it's going to continue or start the debugging session until it's finished debugging. If I don't put any breakpoints. F5 basically means continue to the next breakpoint or to the end of the code. F9, we'll start at F11. F11 means step into the code. F10 means step over, right? Let's say I don't want to run a function or something like that, or run a method, I'll step over it. And then F9 means step out of. This looks like it's not hitting that, it's not going to hit that debug. Maybe I need to build. Normally when you debug, it builds for you. This one's taking quite a bit because my PC is just chugging. Oops, I didn't mean to do that. 1 second. There we go, we stopped. Fantastic. I'm going to go ahead and bring this over. I don't know if it's going to stay here. It won't, but that's fine. So right now it stopped. You can see there's really nothing here at the moment because the only thing that initialized was counter. If I scroll over counter, or if I look at, it's froze for me. I said, I need to update my PC. It is quite aged. Here we go. All right. It's trying to find the processor cycles. Give it some time. So here we go. At the bottom here, you can see the autos. Counter is 0 of data type int. This is what we want to see. I'm going to click into it so I can F11. Because this is true, the while loop is always going to loop until I tell it to stop. So let's go ahead and click F11. You can see we're going to step into it one at a time. So counter is not greater than 5. Counter is 0. You can see here as I scroll over it. So what's going to happen is it's going to skip this break. Counter is not 3. So it's going to skip this continue. Comes down to hello world, prints it, and we're going to iterate counter by 1. Right now, counter is 0 because this line has not run. When I run the line, now counter is 1. All right. It's then going to look here and say, oh, this is the end of the loop. I need to go back to the top. Now I'm back to the top again. You can see it printed hello world the first time in my console here on the right. That was the 0th iteration. Now my counter is 1. Let's go ahead and loop again. So while counter is 1, well, it's still not greater than 5, so we're not going to break. It's still not 3, so we're not going to continue. It should print hello world a second time in the first iteration. Remember what I said about computer science? We start counting at 0, so I'm purposefully stating the 0th iteration, the first iteration, the second iteration. Not that we only did 2 iterations or we only did 1. I want to count the right way so you understand what we are actually looking at because we started at 0. So right now, we should have gotten another print. There we go. Hello world printed twice. And the counter is going to iterate one more time because we said counter plus plus, which actually is shorthand for counter equals counter plus 1. So now this will be 2 after I F11. Now counter is 2. You can see it down here. It updated to 2. We go back to the top again. Well, my while loop is always true, so it's going to fall in 2. is not greater than 5, so it's not going to break. 2 does not equal 3, so it's not going to continue. So we get to hello world, it prints it a third time. You can see it there. The counter counter is still 2 because this line hasn't run yet, but once this line runs, counter is now 3. Now we have some exit conditions that we're going to encounter. We get back to the top, while is always true, so we're going to fall into the loop. The counter is 3, right? 3 is not greater than 5, therefore it will not break. 3 is equal to 3. You see how that says true? If I scroll up here, this will say false on the right side. This will say true. There we are. We are true. So therefore, it's going to continue. What's going to happen? It did not go down and run this any more times. Now that's a problem. That's a big problem. We have something wrong with our code. What do you think's wrong with the code? It looks like counter is always going to be 3. And the reason why counter is always going to be 3 is because the incrementer is below our exit condition. So before I exit, what I need to do, we're going to stop debugging for a second because you can't modify the code while you're debugging. What I'm going to do is I'm going to add a counter here. Why would I add the counter above the continue? Well, so that it actually stops. Counter. There. Save. And I also need to go to REPL because what that means is this is still running. It never stopped. There. Stop. Cool. It just kept on looping through it. And that's not what we want. So now let's try to run it again. So we're going to debug. Boom shakalaka, we're in. I'm not going to waste my time debugging the first 3 iterations. So we're going to get, this is counter equals 0. I'm going to F5. We're back to true again. Counter equals 1. Look down here. Counter equals 1. Great. Counter equals 2. Counter equals 3. All right, we're at the 3rd iteration. We already have 3 hello worlds. Let's see if we fixed our issue. Let's see if we fixed our logic error. Because what I did there was a logic error. No, I did not do that on purpose. That was purely by accident. I'm developing this off the top of my head. This happens all the time. And it's important to debug your code to make sure that it actually runs the way you expect it to. So counter is not less than 5, or counter is not greater than 5, my apologies. So this is false. That means that this if statement won't run. Counter does equal 3. So this is true if it lets the debug happen. And it's telling me it doesn't want to do it. But either way, counter does equal 3. This is true. It's going to actually go into these programming statements in the if. Now, you're probably asking, why didn't you do else if? With exit conditions, you do not want to branch your exit conditions together. You want your exit conditions to exist in their own if. Because if this is true, then it will stop there. If that is true, it will stop there. But what happens if they're both true? Now, right now, they're not both true because I specifically wrote them the right way. But sometimes you might not realize that you wrote the same Boolean expression in a different way, in a different if, and you're not really doing yourself a service by doing that. So keep them separated. Always have your exit conditions separated into their own ifs. Either way, counter equals 3. We're going to increment counter by 1, and then we're going to continue. If I put counter plus plus below continue, I would have gotten an error, and the error would have said code not reachable because the continue will not allow anything below it to run. It'll go to the top of the stack, wherever that is. And in this case, the top of the stack is the while loop. The continue is not telling the while loop to stop looping altogether. It's just saying, I don't want you to continue with this specific loop, this specific iteration. So as you can see, continue is going to ignore these 2 lines down here and go to the top. Now, before I continue, I want to talk about things that might be advanced. What is happy path? What is unhappy path? Happy path is when our code works the way we designed it, the way the requirements have asked us to design it and write it. That is happy path. Unhappy path are all the conditions that we could possibly run into that are not desirable. We have to care for unhappy path as much as we care for happy path. Now, the way I wrote this code is industry standard because we want our unhappy paths to be evident. When you read this code, the unhappy path is explicit. It is obvious. It is evident. When counter is greater than 5, I don't want you to run this loop anymore. When the counter is 3, I don't want you to run this iteration anymore. Those are two very specific exit conditions that care for unhappy path. Now, what's interesting though, is you notice that the stuff I want to happen is below my exit conditions. Because if my exit conditions prove to be false, then yeah, go ahead and run the code that I want you to run. There's no if else, then there, therefore, therefore, however, hitherto and an no. It's just what I don't want to happen and what I do want to happen. So right now, we're at the last iteration, presumptively, because we're at the 5th iteration. And we know that once counter equals 5, this is going to be true. It's going to break the loop. But let's test that. Counter is 4. It does not equal 5. Therefore, this is false. That will not run. Counter is 4. It does not equal 3. This is false. That means that this will not run. So it will print hello world a 4th time, which is what I predicted in the first pass, and I was wrong because I didn't increment the counter like I was supposed to in my exit condition for continue. Now my counter equals 5. Now what's interesting is now that my counter equals 5 and I have printed this the amount of times that I have desired to print it, this is going to catch. If counter is greater than 5, counter is not greater than 5. I should have said greater than or equal to. This isn't going to work the way I want it to. This is why you debug. So we're going to say greater than or equal to. We're going to run that again. Cool. This time I'm going to F5 to 4. 1, 2, 3, 4, 5. Cool. Now we're at 5. I said I was going to increment to 4, but I meant 5. Counter is 5. What should happen? Well, as long as counter is greater than or equal to 5, now that's true. You could have also said greater than 4, but that doesn't mean this one is a little more clear, right? I know I want to stop at 5. So when we're greater than or equal to 5, I want you to stop looping. And notice what just happened. It didn't go to the end of the loop. It didn't go to the top of the loop. It went to the last line after the loop to run the code after the loop. Right now, we have no code after the loop, so it ends. And as you can see, this ended. We have 4 hello worlds. I've been having a lot of fun doing these videos, so I want you guys to take some time to actually dig deep into whiles, get to know them very well, and then use these industry standards to get you into a place where you're developing for the real world. Either way, as I say in all of my videos, if you liked what you saw, please like and subscribe. Don't wait till the last minute. And look out for more content. And as I say in all my videos, good luck. Have fun. Ciao.